Let's determine if two functions are inverses of one another. So you're going to be basically given two functions and you're trying to see is one function an inverse of the other and vice versa. Now, there's a couple different ways you can find this out, but there is a concept with this and a property of inverses. That is, if you take the function and the inverse and compose it together, do a function composition, you get the answer out of x, then those are inverses, okay? And also, if you do the inverse composed with the original function of x and you get x, those are inverses. So you're kind of just proving that if you do the function composition, you get out x. Now, it is very, very rare that you do the, like, let's say you've given two functions f and g and you do f of g of x and you get x, but then you do g of f of x and you don't get x. Okay, that's so rare. There's only very specific functions where that happens. So what we can do is just check this first one. Can we compose these two together and get x out? If we do, these two are inverses of each other. Okay? All right, so let's try that first method with this first example. Are the following functions inverses? So f of x is 7x minus 3. G of x is x plus 3 over 7. So we want to do f of g of x. So f of g of x, goodness, equals, now remember how we do this. We start with the function f, that's 7x minus 3. And everywhere there is an x, you're putting parentheses. So 7 parentheses minus 3. And then the second function listed is going to be what's inside that parentheses. So g of x is x plus 3 over 7. That's going on the inside. So x plus 3 over 7 goes in that parentheses. Now, simplify. So we've got a 7 outside and a 7 in the denominator. So those are going to cancel. That's going to leave me with x plus 3, and then we have the minus 3, and obviously 3 minus 3 goes away, and that is just x. So are these inverses of each other? In this case, yes. Okay, so I do want to show you one other method, and that is, so that was method 1. Method 2 is find f inverse of x and compare to g of x. All right, this is honestly like either method is fine. You decide what works best for you. If you can remember doing f of g of x, you can do that. If you can remember this, then that's fine, okay? So what we're going to do is take f of x, which is, let's rewrite it. F of x is 7x minus 3, and we want to find the inverse. This is great practice for doing that. So finding the inverse of this, we would change this to y. So y equals 7x minus 3. We're going to swap x and y. So this is x equals 7y minus 3. Solve for y. So add 3. That's x plus 3 equals 7y. Divide by 7. And we get y equals x plus 3 over 7. And remember, this y is not the same as the original. This is our f inverse. So our inverse is x plus 3 over 7. And you're checking, is this the same as g? And you can see clearly that it is. So now we have confirmation that that is the inverse. So again, it's whatever you feel most comfortable doing. You can do it either way. Let's do an example here with these other ones. So f of x is 4x minus 6 and g of x is x over 4 plus 6. We're going to do f of g of x. Okay, so starting off with f, we have 4 parentheses minus 6. What's going in that parentheses? It's the x over 4 plus 6. Now, we're going to distribute the 4. So 4 times x over 4 is 4. I'm just going to write this out so we can see it. 4 times x over 4 plus 4 times 6 is 24 minus 6. Okay, so here the 4's cancel and I have x, and then 24 minus 6 is 18. Is that equal to x? No. No, that should just be equal to x there. That's the key. We don't want this to equal the other function. We want it to equal x. So here this would be no. So that was method 1. Let's try the other method, and that would be finding the inverse of this one. So we've got f of x equals 4x minus 6, y equals 4x minus 6, x equals 4y minus 6, swapping our x and y. Solve for y by adding 6. X plus 6 equals 4y. Divide by 4. So we get our inverse to be x plus 6 over 4. Now, if it's difficult to see, because this is what we're checking it with, x divided by 4 over 6, separate this into two fractions, x over 4 plus 6 over 4, and now it's easier to see that the x over 4 is the same, but then this the original function inverse is 6 over 4, while g of x is just 6. So those are not identical, so therefore these two are not inverses of each other.